In this problem, we're being asked to determine if a function is a solution to a differential equation. So remember, differential equations are those equations where we have both the function and its derivative, or maybe some further derivative than the first one, in a relationship. So here's our differential equation right here. And you can see, well, y is going to be a function of t, and our differential equation says t times the derivative of the whole function y minus 4 times the whole function is going to equal 4t squared plus 15t. Our job is to determine if that relationship can hold if any of these is the function y. So this is actually going to be quite a bit of work to do. These are kind of long and tedious problems to carry out because you need to take we need the derivative of y here, so we have to take the derivative of all of these functions and then just set this up, plug and crunch, do the algebra to see if they do indeed equal 4t squared plus 15t. So let's go ahead and start by taking the derivative of each of these possible functions. So let's see, this would be 12t to the third minus 4t minus 5. And I'm going to be very careful here to review my work and make sure I'm not making mistakes. Hopefully that'll be the case. This is going to be 8e to the 4t. And then this one is going to be negative 4t minus 5 minus 8t cubed. And this is going to be negative 4t minus 5. And here we've got y prime equals 0. And here we've got y prime equals negative 3t squared minus 5. Okay, just scanning back over my work here, making sure this looks right. Okay, now we can start plugging and crunching in. We've got everything we need. We have y prime, so we can put it into this differential equation up here and see if it works. There are a couple I'm going to try to eliminate right away. I don't think this one is going to work because if y prime equals 0, we're going to have t times 0, and then the function itself equals 4. Negative 16 does not equal 4t squared plus 15, so that one's out. I also don't think this one's going to work, but let's plug it in. We'd have t times, the derivative, 8e to the 4t minus 4 times the function, which would be 8e to the 4t. That's actually 0, and 0 is not the same thing as 4t squared plus 15t. So that one's out. These others, I think I'd have to plug and crunch. So let's get on to that, and we're putting it in this form here: t times the derivative of y. So that's for this first one, that's 12t cubed minus 4t minus 5. And then minus 4 times the original function y. So that's, in this case, 3t to the fourth. This one might work. Minus 2t squared minus 5t. And that's all got to equal that 4t squared plus 15. So 4t squared plus 15. Okay, 15t. Great. So we multiply the t through here. We get 12t to the fourth minus 4t squared minus 5t. And putting a negative 4 through here, we get minus 12t to the fourth, plus 8t squared plus 20t. This is looking good. So the positive and negative 12t to the fourth go away. We've got 4t squared, negative 4t squared and 8t squared. That comes out to 4t squared. And a negative 5t and plus 20t is plus 15t. Look at that. Boom. So we found one. This one works. Do the others? Well, we've got to go through that same process again. So it's going to be t times the derivative. Let's do this one here, times negative 4t minus 5 minus 8t cubed, minus 4 times the original function, so negative 2t squared minus 5t minus 2t to the fourth, and that's all got to equal 4t squared plus 15t. Okay, again, we'll multiply through the t, so negative 4t squared minus 5t minus 8t to the fourth, and then we've got plus, multiplying the negative 4 through here, plus 8t squared plus 20t plus 8t to the fourth. And this is coming out like the last one did. Those go away, and 4t, negative 4t squared and 8t squared, that's 4t squared. And the negative 5t and plus 22 is plus 15t. That's what we're looking for. All right, so we got two of them. Let's try another, the next one. So this one, we're going to have t times the derivative of y, which is negative 4t minus 5, minus 4 times the original function y, negative 2t squared minus 5t, and all that's supposed to equal 4t squared plus 15t. Okay, multiplying the t through, we're going to get negative 4t squared minus 5t. Multiplying the 4 through here, we get positive 8t squared, plus 20t. Same kind of relationship we've had here. This does simplify in the same way, so that equals that. I'll let you do the rest of it. So that one is also satisfying the differential equation. So we've got three so far. We've just got this one left. My hunch is no on this one, but let's double check it. So t times the derivative that's negative 3t squared minus 5, minus 4 times the original function minus t cubed minus 5t, and that's all supposed to equal 4t squared plus 15t. So multiplying the t through, we're going to get minus 3t cubed minus 5t, and then we got plus 4t cubed, and then plus 20t. So we still get that plus 15t, but we've got a cubed term here and not a squared term. So looks like that one does not work either. So we found three that satisfy this differential equation. If there were an easier way to do this, I would definitely share it with you, but this is how I know how to do these. So I wish you luck.